Okay, we're going to look at 2-bromobutane. In the past, this is how we would draw it. But now, since we've been introduced to the fact that a carbon that has 4 different things attached to it has no plane of symmetry, there will be 2 different 2-bromobutanes. One with the bromine coming out, like this, and one with the bromine going back, like this. Now we don't have the H shown, but I'm going to draw in the H. So we have H going back here, and then we have the H coming out when we have this one. Now, let's take this apart and look at it a little bit and draw it with some perspective. So if I take the bromine like this, and then put the methyl group that's on that sp3 carbon, here's our methyl group, and then on the other side, this one's coming out at me. This is my CH2, CH3, my ethyl group. And then I'm going to draw the H going back. So we're just focusing right on this sp3 carbon. If I have a mirror in between, so this line is going to be the mirror. And then I redraw this molecule through this mirror. I have my CH3 here going up to my carbon with my bromine. These are both in the plane of my tablet. And then this is coming out at me. There's the ethyl group. And the H is going back. So these 2 compounds are mirror images of each other. Now to prove that they're non-superimposable, what I want you to do is practice seeing in your head. I'm going to rotate 180 degrees around this carbon bromine as an axis. And when I do that, what I'll do is I'll flip this over, and here is the CH3 on the other side. Now, when this moves over to this side, the H moves to the forward position, and the CH3 moves to the back, or the ethyl group moves to the back position. So if I take this and put it right underneath, you can see that the 2 images don't line up. They are non-superimposable mirror images. I'll move this right on back to where it was because these 2 are on the same side of the mirror, so these 2 are the same molecule. So if they're both 2-bromobutane, but they're different than each other, we have to have a way to designate one from the other. What we're going to do is learn what is called absolute configuration. Absolute configuration is a way of telling the right hand from the left hand. We don't call it right and left. We call it R for rectus, which stands for clockwise, and S, which is sinister, which stands for counterclockwise. So now, how are we going to get a clockwise and a counterclockwise rotation around these 2 molecules? We're going to use rules very similar to what we used for Entgegen and Zusammen, the Cahn-Ingold-Prelog rules, where we rank the substituents from the first point of difference according to their atomic number. So we have bromine, which beats these 2 carbons, and it gets the 1. And then this carbon on the ethyl group beats this carbon on the methyl group because this carbon is attached to 2 H's and a C, and this carbon is attached to 3 H's. So that gets the 2. The methyl group gets the 3, and the H gets the 4. Once you have ranked all 4 substituents on the chiral carbon, you arrange it so the number 4 substituent is going back. Since this one is going back already, then what you do is you look at 1 to 2 to 3. So this molecule on the left-hand side, if you look 1 to 2 to 3, is going around counterclockwise. This is the S2-bromobutane stereoisomer. If we look at this one over here, since it's the mirror image, it better be the R stereoisomer. So we put the numbers again, 1, 2, 3, and 4. 4 is arranged so it's going away from you, so you're looking around 1 to 2 to 3. Is the R. That is a clockwise rotation. Well, let's look at these little molecules that I drew over here. If I do it drawing it this way, which one does this one match up with? Here's a bromine, 1, 2, 3. H is going away from us. So the way I've drawn it here, this one is the R. So this compound right here matches this one over here. So if we look at this one, we're going to number it also 1, 2, 3. And you say, wait a second, that's still clockwise. But remember, the H is coming out at you, so it will be the opposite of what you see, which will be important as we do different kinds of projections. So this is the opposite of what you see, because the H is coming out at you. And so this one is S. So this matches the first one right here. So let's go through those rules again. 1. Rank the substituents on the sp3 carbons according to atomic number 1 through 4. And this is again from the first point of difference, 1 through 4. Number 2, rotate or arrange so that number 4 is going away from you, is on the back side of the carbon. And then number 3, what you want to do is look at the rotation 1 to 2 to 3. If it follows this direction, it's R or rectus. If it's 1 to 2 to 3, it follows this direction, it's S or sinister.